Hi, my name is Andrew Peterson, and I'm in group 3, and next week we're doing experiment number 5, the jet engine experiment. So before we get into its background about what we're working with, the equipment that we're working with is a model that's based off of a type of reserve power plant that's called a gas turbine peaker power plant. What they do is that during high points in time of energy use, such as like here in Louisiana, if like everyone has their AC on between like 10 and like 4, these would turn on and produce more power to the grid, so everything could keep running. The cycle that we're working with in this experiment is the Brayton cycle. So what I have up here is that's the ideal cycle for it. Okay. Okay, so the air would come in through the inlet for the compressor, where it would increase both pressure and temperature. Come in, it would then go for the combustor, which is where all the fuel would burn, increasing temperature, pressure, and the enthalpy, and then feed to the turbine, where it would drive the compressor for keep working, decreasing temperature and pressure, which for the engine it would shoot out the back and then propelling the aircraft. But for it would then push into the generator to turn the second turbine to produce the power needed. This is a representation of the equipment we'll be using. We'll be working with, first of all, I did we'd not be working that much with the kinetic energy and potential energy. Potential energy will not change throughout the system. Kinetic energy might change based off, since the mass flow would stay relatively the same throughout the system, it would only change based off of the area of the inlet versus the area of the outlet. We would be finding the efficiency of both the first turbine within the engine and the second turbine that drives the drives the alternator. Will be fine. That's why I have the efficiency equation. Okay. So this is the entire system turbogen. The engine inside is a research engine. While it's not used for practical purposes, it's more of a research. It's used to burn different types of fuels and testing their efficiency of power they generate. At the computer over there with our software that will be recording the data throughout time. There are different sensors throughout the system. At the inlet, after the compressor, after combustion, that will be measuring the pressure and the temperature. We can then use that to use off of thermodynamic air tables to be able to find enthalpy for each stage, so we can find the power at different transfer for different stages. Okay. Our experiment goals is to observe the Brayton cycle in a practical manner. We'll be recording the voltage generated from the alternator as well as the power generated from the turbine. And I said in the last slide, we find the FLP as the stage, find energy gain or loss throughout the system. Okay, so for safety purposes, we'd be wearing our normal lab attire, safety glasses, long pants, closed-toed shoes, because we wouldn't be laying there without them. But for this experiment, it said we would be needing hearing protections that everyone within the room. And then, in case something goes wrong, we're required to have the fire extinguisher in case it catches fire. Hopefully it doesn't. Okay. So the first stage is the preset setup where it's make sure the wheels are locked, keys turned off, throttle set to minimum power, so when we turn on, it doesn't just immediately whirl up and damage itself or anyone else. Make sure it's clean, like doesn't have any paper in the inlet outlet. And we make sure that the system is able to be recorded according to information. So, start procedure. We make sure before we start the engine that all the rings read 0, so there's no offset at the beginning. Read the procedure. It said that we run the engine at full throttle, but we try not to exceed the engine's max RPM of 28,000. And for the generator, there is a separate load throttle, similar to the steam engine that was done the previous week from our group, that will slow down or speed up the RPM. It has a max 8,000 RPM, but it does have an automatic shut off at 10,000, just in case something goes wrong. And during that time, there will be an Excel spreadsheet being recorded that records that records temperatures, pressures at the 5 different points in the system, as well as the voltage generated from the alternator and the power from the turbine within the engine. Are there any questions?
Yeah, can you go to the diagram?
Which?
No, yeah, yes.
Yeah.
What type of compressor is that?
Compressor. What type?
Yeah, what type of compressor is that? Does anyone know the type of compressor that is there? This comes have killed some people. It's actually a centrifugal compressor. Yeah, centrifugal,
Just for
yeah. It takes in air and exits air at 90 degrees. Like air goes in this way, comes out this way. So take note of that. Then what about the turbine? What type of turbine is that?
That would also be centrifugal.
No. If you look at the top, the air goes in this way, the air comes out this way. Like it goes in the same direction. So we call that axial.
Axial?
Yeah, axial. A-X-I-A-L. So we actually have axial. Axial. Is that the pronunciation?
Yeah.
Axial. Okay.
That makes sense. Straight through.
Yes, straight through. Yeah. So we have the axial compressor and we also have the axial turbine. Same thing. We have the centrifugal turbine and centrifugal compressor. The only difference is the way they take in air and the way they exit air. Just make sure you know that.
Is it just those two or are there different types?
Yeah, those two, majorly those two.
Okay.
Okay, that's all. Right, can go to it.
Okay, cool.